All right, let's get right into it. Welcome to this explainer. Today, we are taking a journey that is going to completely challenge your assumptions about extreme environments. We're going to venture away from that familiar glowing orb in our night sky and plunge straight down into the crushing, absolute darkness of our own planet's abyss. Get ready, because what we thought we knew about the boundaries of life and where to look for it is about to be totally turned upside down. Okay, let's dive into this. Have you ever heard the claim that we know more about the surface of the moon or even Mars than we do about our own deep sea? You know, it's a fact that's been repeated by legendary science communicators for decades. And it sounds super poetic, right? But here's the truth. It has absolutely no scientific basis whatsoever. It's a really seductive idea, but it's roughly 70 years out of date. So to put things into perspective, 23.4% of the world's seafloor has actually been mapped to a high resolution using modern acoustic data. That's 46 million square miles. That mapped area alone is about 3 times the total surface area of the moon. We so easily accept the moon because, well, it tangibly intrudes on our lives. We can just look up and see it. But mapping the incredibly dynamic 3-dimensional ocean floor in high resolution, that is a massive and honestly often ignored achievement. And the myth doesn't stop at just maps. It extends to human exploration, too. We constantly hear that more people have walked on the moon than have visited the deepest trench in the ocean. Again, the numbers tell a completely different story. Only 12 people have set foot on the moon, but between 27 and 40 people have visited the Challenger Deep down in the Mariana Trench since the bathyscaphe Trieste made its first crewed descent back in 1960. Let's move to the timeline and see how this builds. Because as the decades passed, this deep sea exploration started yielding some incredible results. In 1960, we had that historic first descent to the Challenger Deep. In 1969, humanity walked on the moon. But then we hit 1977, and a truly paradigm-shifting discovery was made right back here on Earth. An event that literally rewrote the biology textbooks. In 1977, a team of scientists, including Jack Corliss, Richard von Hertzen, and Robert Ballard, used the Alvin submersible to explore the Galapagos Rift. They were basically just looking for evidence of underwater hot springs. Down there, in the pitch black, they expected to find absolutely nothing but barren basaltic rock. Instead, looking out the porthole, Corliss, Tjeerd van Andel, and pilot Jack Donnelly were absolutely floored. They discovered a thriving, completely alien oasis of life. Giant tube worms, clams, shrimp, all just flourishing in complete and total darkness. And this brilliantly illustrates exactly what they found. These are black smokers. Just look at these towering, rocky chimneys sitting on the seafloor, spewing these dramatic, dark, particle-laden plumes. What you're seeing is superheated, chemical-rich fluid billowing up from deep within the Earth's crust, forcefully colliding with near-freezing 2 degrees Celsius deep-sea water. The chemistry behind this smoke is absolutely fascinating. Cold seawater percolates down through fissures in the ocean crust. Magma then superheats this water, dissolving minerals into it. When this hot, buoyant fluid shoots back up and hits the cold ocean water, a massive chemical reaction occurs. Minerals rapidly precipitate out of the liquid, forming these solid chimneys. It's exactly like that classic high school chemistry experiment where you mix magnesium sulfate and sodium carbonate to form a solid white precipitate. And get this, in the wild, these rocky vent chimneys can grow up to 30 centimeters. That's a whole foot per day. No way, right? Now, what's really interesting about this view is the base of the chimney. See those bizarre creatures? They are thriving right next to toxic, scalding plumes of heavy metals and hydrogen sulfide. Prior to 1977, the absolute rule of science dictated that all life on Earth fundamentally relied on the sun. So, how on earth were these animals surviving? Well, the answer is chemosynthesis. This was the game-changing concept that emerged from the deep. Instead of using sunlight to turn carbon dioxide into food, like plants do in photosynthesis, the organisms down here use chemical energy. They literally use the toxic hydrogen sulfide spewing from the vents to power their biology. It proved, once and for all, that you do not need a sun for an ecosystem to survive and flourish. And the poster child for this alien ecosystem is Riftia pachytyla, a giant tube worm. Imagine a worm up to 6 feet tall, topped with a brilliant deep red plume, just living under a crushing 3,000 psi of pressure. But here is the craziest part. It has no mouth. It completely lacks a digestive system. That's right, no mouth, no stomach.
It survives by relying entirely on billions of symbiotic bacteria living deep inside its body to perform chemosynthesis and feed it sugars. Recently, researchers at Harvard, led by Jessica Mitchell and Peter Gerges, uncovered exactly how these internal bacteria pull this off. Most organisms use just one pathway to fix carbon, but these bacteria, they use two. It's kind of like a hybrid car, seamlessly switching between gas and electric power depending on the conditions. They use the RTCA cycle when energy and sulfides are low, and then boom, they instantly switch to the CBB cycle when sulfides are abundant. This dual pathway system allows them to adapt incredibly fast to the wildly fluctuating, violent chemistry of the hydrothermal vents. So, the crucial point is summarized perfectly by Dr. Gerges here. This tour de force research proves these pathways are very likely run in parallel. This incredibly sophisticated metabolic trick gives these worms unparalleled stability, allowing them to grow remarkably fast and dominate an environment where almost nothing else can survive. It completely redefines what we thought were the absolute limits for life to sustain itself. But, this explainer isn't just about marine biology. It's really about our place in the universe. Look at this rocky structure. This is the famous Lost City hydrothermal field, located on the Atlantis Massif. And this right here shifts our narrative from biological marvels straight into astrobiology. The Lost City is totally unique. Unlike the black smokers we just talked about, it features marine alkaline vents. Through a geological process called serpentinization, rocks from the Earth's mantle react with seawater. And the mind-blowing part? This purely geological, abiotic process naturally produces methane and hydrogen. It creates the fundamental building blocks for microbial life, entirely without biology. It's the perfect proxy for setting how life might spark into existence from bare rock and water. Which leads us perfectly to the cosmic connection. If you look at the conditions of deep-sea vents on Earth, high pressure, absolute darkness, toxic chemicals, and abiotic methane generation, they beautifully mirror the hypothesized conditions on extraterrestrial worlds. Moons like Jupiter's Europa and Saturn's Enceladus, they have these deep, dark, liquid oceans under miles of ice. Our ocean vents provide a working, tangible blueprint for where and how life could exist out there in the solar system. This connection was so powerful that after his 1977 discovery, Jack Corliss completely shifted his scientific career to focus on the origins of life. In 1981, he published a groundbreaking paper hypothesizing that the very origin of life on Earth began right inside these submarine hot springs. Before that, we looked to Darwin's warm little ponds on the surface, but Corliss suggested we actually came from the dark, boiling pressure cooker of the deep sea. So we're going to wrap up this explainer with a question that bridges the abyss to the stars. If life doesn't just survive, but wildly thrives in the toxic, crushing, sunless depths of our own planet, where else in the cosmos is a lost city waiting to be found? It turns out, to understand the heavens, we first had to explore the very bottom of the Earth. Thanks so much for joining me on this deep dive. Keep questioning, keep exploring, and I'll see you next time.